Okay. Good afternoon and welcome to lecture 18 of ECL 706. In this class also we are going to continue our discussion on slab and beam formwork. If you remember, in the last class I had just introduced you to the conventional slab and beam formwork, and we had just started with proprietary formwork for slab and beam. In that we had seen LNT formwork for slab and beam, and there I had given you an example of DOCA flex, LNT flex system. If you remember, we had covered this particular system. Now you can see you are familiar with most of these components now. Just to quickly remind you, you can understand this is a plywood of 12 to 19 mm thickness. This is your H16 beam. Its depth is 160 millimeter. Then another layer of H16 beam, and then you have this props, shores, whatever you say. I introduced you to this beam forming support also, a triangular piece of steel used for forming small beams. So both sides you have this arrangement of truss type steel members. You can use them for small cross sections of beams. Once you use them, you can avoid the uses of timber for your beam sides. Now the same component you can use it for even the sloped roof. In this figure, if you see, this is your sloped roof, right? In this figure you have this flat slab. Here you can see the pitched roof or pitched or sloped roof, whatever you say. So the same component you can use it for casting even the pitched slope also or sloped roof also. So you have the same components, plywood here, then one layer of H16, another layer of H16, then you have this props. Another component which you can see is the tripod. This is known as tripod. This is essentially to bring the stability, to provide the stability to the system. For stability you provide these tripods. Now this particular system is useful for a maximum floor height of 4.5 meter. That means for normal buildings you can find this system to be quite useful. They are quite useful. If your floor to floor, that suppose this is one floor, this is another floor, and height is maximum, let us say 4.5 meter, this system is quite useful. So is that clear to you, technology class? The system is suitable up to a floor to floor height of 4.5 meter. More than this, this system is not that useful. Now when you see these props, they come in number of they come in different sizes. They call it as CT 250, CT 310, CT 340 and CT 410. So CT 410 is the largest prop, and you can go up to 4.5 meter using these props. Okay. So depending on the height of the floor, you can choose an appropriate prop from these combinations of props, from these combinations of available props. Now when it comes to uh, higher floor heights, floor to floor heights. Suppose your floor to floor height is more than 4.5, say for example 6 meter or more than that, the previous system is not that useful, not that useful. So, in such cases you go in for this tower system. So, the source, individual source are now replaced with towers. Have you seen this type of arrangement technology class? Yes? Technology class, can you hear me? Have you seen such type of arrangements anywhere? You can see this is the actual photograph, whereas this is a schematic diagram. The left one is a schematic diagram, the right side is the actual photograph. Now, in the right hand side you can clearly see the H beams, the yellow ones. All these are your H beams or H16 beams. Now, it has got some additional components. For example, this is called short prop. This particular piece is called short prop. And this one is your familiar member veiler. I will give you the cross sections of each of these members, and then this is your tower. This is your tower. I will give you the details for this separately. Just give me few minutes. I will show you how they look like. Just a minute. Short prop is something like this. You have this U head. This is your short prop. Okay. This member is used when you are casting slab and beam together. So, this is your slab portion, this is your beam portion, something like this. So, this caters to the difference in elevation, difference in height, because for this you have to have the bottom here, and for this you have to have the bottom here, bottom shutter here. So, in order to take care of this distance you use the short prop, something like this, something like this. So, this is your short prop. I will tell you how this short prop is erected, but do you understand this short prop? This is a tubular member, the cross section is something like this. If you see here, this is something like this. Is this clear to you, technology class? Okay. Now, I will tell you how does tower look like and what are the individual components that you have to use. Towers are basically made up of basic frames. Made up of basic frames. These frames come essentially in three sizes: 0.9 meter, 1.2 meter and 1.8 meter. So, these are the sizes in which you get the basic frames. Now, one basic frame would look something like this. These are again tubular members. these are roughly about 50 NB pipe, right. Diagonal members are maybe it could be, let us say 25 mm, something of this order. So, do you understand this basic frame? Depending on the type, it could be either this height could be either 0.9 or 1.2 or 1.8 meter. Do you understand this technology, class? Okay. Now, in order to make this as a tower, you do it like this. So, in plan one frame would look something like this. This is in plan one frame. Something like this is in plan. So, if you see this frame from top, it is something like this. I will do it again. So, this is the thickness. These are the bracing members. Yes. So, this is how one frame in plan would look like. Now, in order to make it a tower, you add two frames. So, something like this, one frame here, another frame here, and then you have these braces, plan bracing. So, this is how one tier of tower would look like. Now, this is one frame, the distance could be, this distance could be either 15-20 millimeter or 2250. It comes in these two standard sizes, 15-20 or 2250. So, your plan of the tower could be 1520 by 1520 or 1520 by 2250. So, these two types of towers are possible in typical cases. So, do you understand this technology, class? Do you understand this? Yes. Okay. Now, I will tell you how to join one tier with another. This is to construct one tier using basic frames. Now, I will tell you how to join these two towers. So, at the bottom you have these base plates, or they are known as foot plates. So, at the bottom you have these foot plates. They must be in true level. So, first step is you level them, otherwise there would be problem. Then the foot plate looks something like this, something like this. Then you have a component called tower spindle. I will use different color. These are your tower spindles. They are basically threaded members for height adjustment. Then you have this frame, something like this. One frame, you just bring it and keep it something like this. So, one frame I have kept. Do you understand this technology, class? So, first tier is complete. Both sides, So, in plan if you see, one frame you have brought here, another frame you have brought here, and they are braced together, something like this. So, this is in plan. Now, in order to add another component, what we do is, we have this member, I will show it in different color. We have this member called coupler. You put the coupler inside, these are known as couplers. These couplers have holes at regular interval, here, 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 something like this, right. Now, you bring another frame, so this coupler will be half on the upper frame and half at the bottom frame. Similarly, here also half on the top frame and half at the bottom frame, and then you have some pins. So, these pins are inserted, one at top and another at bottom, one at top, another at bottom. So, this is how you connect these frames, different tiers of frames with each other. Do you understand this technology, class? Okay. Now, in order to add another tower, what you do? You bring the coupler again, put it inside here, half at the bottom, half at the top, bring another layer of frame here, and then put the pin. Okay. So, something like this. This is one frame, another frame, then another frame, something like this, it goes on. So, is this clear to you, technology class? Okay. Now, when it comes to top, let us say this is your top member, this is your top frame. Now, here you will have one more tower spindle, something like this. These are again threaded here, and on this tower spindle you have this member called U head. Its shape is like U, so that is why they are known as U head. So, these are your U head. So, this component is kept on top, right. So, do you understand this technology, class? Okay. So, this is how you construct one tower. This is how you construct one tower. Now, I will show you the actual photograph, it will be more clear to you. Can you see it in the right hand side? They are your foot plate, sorry, just a minute. You can see at the bottom you have this tower spindle and foot plate, then these are your frames, and on top you can notice again tower spindle and U head. So, here you have U head and tower spindle, here you have foot plate and tower spindle. Now, couplers are not visible, couplers remain concealed, because if you see you will not be able to view the couplers because they are inside the frames. See, you will not be able to see this component. So, coupler will not be visible from outside. So, this portion will not be visible from outside. This is what I meant to say. So, is that clear to you, technology class? Now here also you can see these U heads. U heads are located here. Now on this U head you can see this blue component, which is your veiler. So you have these component, one here, another here, and then you keep this veiler here, something like this. Now, as you know, these veilers are something like this, one channel, another channel here, and they have a gap. So your short prop basically comes and sits like this. So this member gets fitted it inside the gap created by the veilers. Do you understand this? Okay. Now this particular member supports your H beam, here you can see. So do you understand how these towers are assembled and how these towers are utilized? Okay. Now these towers you will find they are very strong. Each leg of tower can take 6.25 tons of load. Each leg, that means each tower means 4 legs, can take about 25 tons of load, that means 250 kilonewton. Each tower can take this much load. Now, if you properly brace them, I will tell you how to brace them. See, this is one tower, another tower, something like this. You have this foot plate, now you have these arrangement here. Something like this. I will tell you how to design these towers in one of the lectures. Now, if you are bracing it something like this, I will tell you how to brace it. These towers are to be braced with each other also. This is not there, so this is the correct one. The towers are to be braced with each other also, and if you follow this process, you will find that the load carrying capacity doesn't decrease. Doesn't decrease with increase in height. For example, if your tower is of 10 meter, its load carrying capacity will still be 25 tons. If it is 20 meter, the load carrying capacity would still be 25 tons, provided you are bracing them with some permanent structure at regular intervals as suggested by the manufacturer. Do you understand this technology, class? Do you understand this? If you are properly braced it, these towers can be taken up even up to 100-150 meter height. There is no problem, absolutely. Only thing, at suitable intervals you have to brace it with some permanent structure. And if you are doing that, if you are ensuring that the load carrying capacity of the member doesn't decrease, the towers are very suitable for high load application. So for your factory buildings, for your bridges, major bridges, you find them very useful. I will show you some of the applications when we take up the relevant topics, and that time you will find how these towers become useful. Okay. Now I will tell you some methods through which you can achieve economy in slab formwork. For example, using this L&T formwork system, let's say you are planning to do this concrete of this flat slab. Now you will find that these are your ply sheets, plywood. It could be 1.2 meter by 2.4 meter. So you can notice this is one piece, this is another piece. So the entire piece of plywood you can lay, Now you can notice this strip, small strip in some different color. The width could be of the order of about 300 millimeter. Now the location of this strip has been predefined. I know that once my concrete has gained strength, I will be putting my props at these locations. I will tell you this is known as repropping, okay. This is known as repropping. I will tell you how to fix repropping, but for the time being just understand that you need to keep props for a longer duration at this location. Now this is how I have arranged my formwork. Right, this is how I have arranged my formwork. Now you can see once I have identified these strips, I will reinsert these props here and remove the entire piece here, everything from here. So you can see this particular slide, this particular photo where only the strip is visible, rest all the materials have been removed. Just try to think, just try to see all these 4 steps. Now the reason is why we want to do it like this is, suppose if I keep the whole material for longer duration, my formwork resource is blocked. So I will try to use it as often as possible. So I would like to take the materials as quickly as possible, but without compromising on my stability part. It should not happen that the whole thing gets collapsed. No, I don't want that. That is why I have seen where I should have some number of props left for a longer period. The remaining material I want to take it out. So what I have done, I have chosen a small strip and put separate piece of plywood there, so that under that strip I can keep the reprops and the remaining materials I can remove as quickly as possible, so that I can utilize it at separate location. Do you understand this? Do you understand this? For those of you who are not clear, I will just try to do it with my own sketch. Say this is the plan of slab which I want to do, right? So I have found that if I keep props at these locations, maybe for 14 days, I can remove these props. Let's say these are the prop locations. Suppose this particular row of props I want to keep it for 14 days, right? Whereas other props I can take it out. This is from design calculations, right? So what I do is I keep plywood something like this, bigger pieces of plywood something like this, these are my bigger pieces of plywood, and for this strip I put smaller ones. Maybe this is my, I will use green color, this is my smaller piece of plywood, similarly here also I have smaller pieces of plywood, and then finally I have these bigger pieces. So what is happening here is the bigger pieces of plywood are kept separately with the smaller pieces, so that during removal of formwork they do not obstruct, and you can easily take out the large chunk of material at an early date. So all these things, so finally when I remove this is again in plan, so when I remove this you will find that I am left with only this much. So I am left with this piece of plywood and these 4 plus 4 8 props. Remaining all materials, these plywoods, these props, everything has been removed. Do you understand this technology class? Now is it clear? So what is happening is we are taking the majority of the formwork materials for our reuse, while some portions I am keeping it for a longer duration as per my design requirement. Do you understand this? Not clear? Yes, technology class, not clear? Not clear? Yeah. Okay, I will do it again then. See, this is the slab you want to do. Okay, this area you want to do the slab, right? Now I will tell you how the props would look like. Let me just see if I have some photographs. Can you see the picture in your left hand side? Okay. So you can see the prop location. These are your props. These are your props. Something like this. Okay. Now I want to draw this in plan. So let's say I am concentrating only on props. Is it clear till here? Okay. Now suppose that from your design calculation, I will tell you how to do that. You find that after 7 days you need to keep only these props. Rest you can take it out. Suppose after 6 or 7 days your designer says that you can take out all props except props in this row. Do you understand this? Okay. Now what arrangement you will take so that all these props can be taken out except this row of prop. This red row of prop you want to keep it for longer period. Remaining all the prop as well as plywood S16 beam you want to take it out. What you will do? Suppose you put plywood like this. One piece here, another piece here, 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 one piece here, another piece here. Will it be possible for you to take out props and plywood except for this location? Is it possible? No. So what you do? We will have an arrangement something like this, in which this row we will keep smaller piece of plywood, which will be segregated from remaining portion of plywood, maybe this. So what I have done is, the larger pieces of plywood, they have been kept separately from this smaller piece. The advantage is, now I can take it out all these materials along with props, and I will be left with an arrangement like this. My small strip of plywood and props like this. So all these materials are gone. Now do you understand this? Clear? Okay. So these are some of the ways through which you can think of reusing the formwork materials at a faster pace. So in this manner your cycle time would be shorter. Your cycle time would be shorter, and consequently the cost of formwork would be smaller, I mean cheaper. Fine. Now, if you see this particular slide, especially to your right hand photograph, this one, you can see the similar arrangement what is shown in the left hand side has been used to support what is known as waffles. Have you seen these waffle slabs? They are sometimes also known as ribbed slab. Waffle slab, have you heard of? I will tell you how it looks like. In some of the buildings in Addis, you can notice this kind of slab. So the slab would look something like this. So from inside it will look something like this, right? Something like this. This is the top one. This is the top. Now, each of these waffles you can either do cast in situ or using precast. I will show you both cast in situ as well as precast. These slabs you prefer when you need large column free space. So for large halls, such type of slabs are preferred. You remember this? You might have studied in some course waffle slabs. Yes, technology class? Okay. If you want to see it in plan, it would be something like this. One waffle here, another waffle here, something like this. Something like this. This is in plan. Now it is clear? Okay. Now if you go back to this particular slide, you can see this is a cast in situ waffle slab. So all these waffles are cast in situ. There is another method also in which you have these precast waffles. That I will tell you sometimes later. I will show you the photograph. So these are basically made out of cast in situ is basically made out of FRP molds, fiber reinforced plastic molds. Fiber reinforced plastic molds have been used here so that it gives you very good quality finish, Now you can see some more applications of tower formwork for different applications. For example, in this particular slide, you can see this arrangement for casting curve shaped gallery. Of a sports stadium. Now you can see the different heights of columns, I mean towers, have been arranged, and this is what I was telling you about the bracing. So you can see how the braces are done. One tower here, another tower here, and they are braced something like this. Once you brace it like this, the load carrying capacity doesn't decrease. You have this plywood here, then you have this H beams, and then timber and H beam depending on your requirement. This is the typical cross section. You can see this foot plate, the tower spindle, the basic frames, the tower spindle, U head, and the veilers and H beams. Is this clear to you, technology class? Fine. Now we will see some systems developed by Perry for this slab and beam application. These are again patented, they are modular, they are easy to erect and dismantle, so your cycle time is naturally less, labor cost is cheaper, and consequently you find that the system is more economical. This company offers a number of solutions. I am not going to discuss all of them. The three important ones, what they call it as Skydeck system, grid flex system, and multiflex girder slab formwork system, we are going to discuss. One is Skydeck, then you have this grid flex, and then you have multiflex. Now when it comes to Skydeck system, they consist of a main beam, a panel, drop head, and the cover strip. You can form a slab of thickness varying from 950 millimeter, and beams could be from 300 millimeter width to 600 millimeter depth. They are very light in weight, so even manual handling is possible. This slide shows you how the components are arranged. What you see here is the Skydeck aluminum panels. So this is a frame made up of aluminum, and you can see this ply. So plywood is fixed in this frame. The panel comes in various sizes. You have 1500 millimeter by 750 millimeter, 1500 millimeter by 500 millimeter, 1500 by 375, 750 by 750, 750 by 500, and 750 by 375 millimeter. Once you have got so many combinations, you can virtually form any type of shape in plan. This is how the arrangement looks like in case of Skydeck panel slab formwork. We move on to the next, that is grid flex. These are again light in weight, they are modular, durable. They consist of grid elements of 2000 millimeter length and 1000 millimeter width. You have filler elements of various sizes for varying requirements. They consist of prop heads and props. Plywood panels are here used for sheathing member. If you want to strike it at an early date, you can use the grid flex beams. You can just have a look, different stages in the construction of this formwork system. So starting from the wall, what you notice here is that the worker need not even go on to the top. Right from the bottom they can install, and then one person can go on top to lay the sheathing material. This is multiflex girder slab system. You are already familiar with this G24 beams, okay, of depth 240 millimeter. So they are in two layers. So layer 1 here, layer 2 here. On top you have the plywood. Here also you have these tripods. You may notice that not all props require tripods. Not all props require tripods. About 40% of your props require these tripods, 40 to 60%, okay, depending on your plan of the slab. This gives you another view in which these components have been erected. So, you can see these props here, then you have this beam in perpendicular direction and primary beam, and then you have these secondary beams. So, is that clear to you, technology class? Okay. Now, there is another system of formwork developed by a company called My1, and this formwork system is known as My1 formwork. This system is useful mainly for housing application, especially for mass housing. When you want to construct large number of houses, the system is very suitable, very suitable. Now, almost all the components here are made up of aluminum. All components virtually. This includes your sheathing also. So, here you do not use plywood, everything is made up of aluminum. Now, the system consists of beam components, deck components which is slab components, wall components and some other components such as to form the corners, external corner, internal corner. So, to cater to those elements. Now, you will find that this particular system is useful for a situation like this. Suppose you have some plan. Suppose I am taking a very simple building, right? Now, in order to have a shorter cycle time, the walls, if you see, they are also constructed in RCC. So, all these walls are constructed in RCC. Almost no brick wall. So, the reinforcement for wall and column, beam and slab are tied together, concreting is done together, and you get a very fast cycle time, maybe 3 to 4 days every floor. You can go up to, you can achieve up to that speed. So, the difference is clear. Everything is made up of RCC here. So, you have the shutter ready for wall, columns, beam and slab all put together, then you concrete it and then you dismantle it and then take it to the next level. Now, this is what I have made it in a sequential manner and it will be clear to you. So, if you just see this, this gives you some schematic diagram for wall junction. So, this is your wall junction in plan, and this gives you 3D arrangement for the same using MyOne system. The system is very simple, flexible and cost effective. Since factory made formworks are available, you can get very high accuracy. You can reuse these systems for as high as 250 times. 4 to 5 days cycle time for floor to floor construction is possible, and that makes the contractor very happy because it's a profitable thing for him. Okay. Now I will give you some steps so that you can understand the working method for this MyOne formwork. So in step 1 you find that you have to perform this setting out and carry out the survey. So you complete the survey work, then you do the vertical rebar fixing. You can see some worker here and he is tying the reinforcement. Are these slides clear to you, technology class? Can you see the sketches clearly? Okay. In step 2, rather in step 3, you can see you are trying to put the shutter for wall, column and beam. So this is the arrangement for wall. This is the arrangement for beam, and you can see if you have some door opening, this is kept here. This is the position of the door. Clear? Okay. Now this is the arrangement for deck or the slab formwork. So you can see this member, no longer plywood, they are aluminum panels. This is the top. They are supported on these props, again made out of aluminum. All these props you can see, they come in exact sizes. You can notice the openings also. Clear? You can see the slab reinforcement and some mechanical and electrical works such as plumbing, putting electrical conduits, those works are in progress. You can see this. Now in step 6 you perform some formwork fixing for sunken portion for toilets and other places. Fix the spacer and vertical soldier. Then you check the vertical and horizontal alignment, whether they are in plumb, all those things you have to see. Then you pour the concrete, compact it. So this is what is happening here. Once it has set, you strike the wall formwork first. So you can see people dismantling the wall formwork. Now sometimes you will find that in slab itself people leave certain openings. Okay, you can notice this opening here. These openings are useful for taking the material from lower floor to upper floor. Is it clear to you in this picture? Is it clear? Some openings have been left in the slab so that you can take out the material from lower floors to the upper floor, because everything is closed, all walls you have cast. So you have to take some staircase to take the material to upper floors. So that will take time. So what they do, at some convenient locations, predefined locations, they have certain openings through which they can take the material on upper floors. Is that clear? Clear? Just see this slide, just see this picture. Okay, I will enlarge it and then it will be clear to you.
Hello?
Yes.
The question is, what can you do against this opening finally?
Can you repeat the question?
What can you do against this opening finally? That means after the construction.
First you tell me, is this drawing, is this figure clear to you, photograph? Can you notice the opening here in the slab?
Yes, yes.
And can you see these two workers trying to push this through this opening?
You can't see.
You can't see?
Yes, you can't see.
Okay. Now tell me, what is your doubt?
The question is, what you can do against this opening after the construction.
What can we do at the time of?
After end of construction, against this opening.
Okay, what to do with this? We fill it up, we fill it up.
How?
You grout it. What you do, you put some shutter piece here at the bottom and then grout it from the top. That's it. Clear? What is done is, since these are as per design, already the reinforcement would have been provided. Diagonal reinforcement at these openings should be provided. So all those things are already taken care of. It is not that at the time of execution we put some hole somewhere. No, they are all designed. They are all designed. Clear? Yes? Okay.
What about the reinforcement where you tell us there can be high
Here reinforcement.
for this opening?
No need. I will tell you how it is done. Suppose this is your wall. I am giving you example of wall, and you have some opening here. Okay. Now there are design methods through which you will find that it is possible to put some additional reinforcement here, and here, as well as some diagonally here. So even if there is no reinforcement here, zero reinforcement here, it is able to take care of its own as well as some additional load. So these members, these reinforcement are designed. Is this clear? So no need to have any reinforcement later. No need. There are standard design processes through which you design these openings, design of openings. You can refer to some of your textbooks which tells you how to do this. There are certain diagonal reinforcement that you have to provide. they tell you what should be the spacing of those diagonal reinforcements and so on. So, is this clear to you, technology class?
Yes, it is.
Okay, fine. Okay, so some photographs I will show you so that it makes it brings more clarity to you. This is again just the repetition. I am just showing you some good photographs. So this is your plywood H16, H16 here also, then props, T head like this. This is side photograph. Is it visible to you? So you can notice how far the props are spread and how much area you are getting at the bottom. In conventional formwork, what you will find is, suppose this is your area slab here, you will find all these cramped up. It will not be possible for you to go inside. You have seen such type of arrangement? Now see this. You can go easily here and have fun, right? But in this arrangement, you will have to take lot of risk to go inside. Now, if you cannot go inside, how will you know what is happening? Whether there is slurry leakage, whether there is some prop which needs tightening, whether there is some props which needs loosening. All those things are not possible here, and that's why you find after desuttering many problems are noticed. In this, at the time of pouring itself, somebody can go inside and just see how the things are done at that point of time. So clear? Okay, some more slides. Okay, this you have already seen, but just for more clarity, this is also known to you now. This is how in actual practice it looks like. A very tall structure with floor to floor height of the order of maybe 8 to 9 meter. You can see the arrangement for beam is being done here, being performed here, and using these heavy duty, these are sometimes also known as heavy duty tower. This is because of its high load carrying capacity. Okay, so we stop at this point of time, and I just quickly summarize whatever we learnt in this particular lecture. We started our discussion with L&T formwork. We recapitulated whatever we did yesterday. That was L&T flex formwork system used for a floor to floor height up to 4.5 meter. Then we moved on to see heavy duty tower, how it is assembled, what are the various components. I told you about the basic frames, I told you about the foot plate, tower spindle, U head, and some veilers, short props. These are used to form your slabs of large heights. Then we saw some 2-3 systems of Perry. Then we moved on to a system called Maiwan formwork, wherein everything is made up of aluminum, including your sheathing member. We saw a step by step process of Maiwan formwork working system, and in the next lecture we will see how to design a slab and wall formwork system, both the conventional as well as proprietary slab and beam formwork system. So if you have any doubt, please feel free to ask. Thank you.
No doubt. Thank you.
Thank you and good night.